All right, the next class of molecules are called amines. And so far, we've only talked about molecules that have C, H, O are the main atoms. We have brought in some halogens like F, Cl, Br, and I, but nitrogen is big in organic um, compounds. And so these are all based on derivatives of ammonia. And so here is ammonia right here. It's N attached to three H's. If I replace one of the H's with a alkyl group, um, I get a primary amine. If I replace two of them, I get a secondary amine and all three tertiary amine. Physical properties. Which of the amines blank and blank can H bond with each other? Well, for hydrogen bonding to occur, I need an H attached to an O, N, or F. So here I'm talking about an N. Um, this has an H attached to an N. This has an H attached to an N. This does not. So the answer here is primary and secondary amines can H bond with each other. Tertiary cannot. Therefore, melting points and boiling points are high, and I have an example here. Oh, just to show, um, here's a very negative portion of the N. Here's a positive H. I'm going to get some attraction between these two. These things are going to be held closer together, and physical properties will be dependent upon them. Here's a tertiary amine, N attached to three methyl groups. Here is N attached to two H's and a propyl group. And just to show, this thing will hydrogen bond because it's a primary amine. This will not hydrogen bond. Yes. Look at the effect here, because this will not hydrogen bond. Boiling point, basically 3 degrees Celsius. Here, boiling point, almost 50 degrees Celsius, all because of hydrogen bonding. And these things have the identical molecular formula. Both have 3 carbons and 9 H's. They all hydrogen bond with water, so they will be soluble in water. They're found widely in nature. When you smell that fishy smell or rotting fish flesh smell, that's an amine. And they act like a weak base. Yes? Because if I have N and there's H plus ions floating around in solution, these things will be attracted to each other. And basically this N will take these out of the system. Naming, I take the longest R group, or longest alkyl group. Off the N is going to be the root, and the ending will be amine. And is going to be my root. And I'll put it in action. So here I've got a primary amine, propyl. Where is it attached to the N? It's attached off of number 2. So this is going to be 2 prop and here I've got 2 alkyl groups, one here, one here. The bigger one is this one, so this is going to be ethanamine, but I've got to say where this methyl group, where this methyl group is, it's attached where? It's attached to the N. So we actually use the letter N as a locator here. So this is N, whoops, methyl, F, and here I'm going back to my red. I've got something over here is my longest chain. Here's my longest chain right here. So it's going to be 1, 2, 3, 4, 5. It is going to be pentanamine will be the root, but I've got a methyl group here and a methyl group here. Where are they? I'm going to number this as 1, 2, 3. So this is going to be 2, comma, N dash dimethyl. Just to recap that, I've got methyl groups attached to carbon number 2 and the N. 2N dimethyl 3 pentanamine. And then one more example, I've got this guy up here. I'll just put the name down here. I've got an ethyl group, a methyl group, and a methyl group. So my root's going to be with F. The two methyl groups are off of N's, so I'm going to go N, comma, N dash dimethyl. Ethane, get out of here. Ethanamine. No need for a number here because I have to be attached to number 1. Here, I can be attached to a few different places. And that's what you need to know about amines.